Yes, with a turkey baster, I'm going to destroy this idea that we could possibly have atmospheric pressure, right, gas pressure on the Earth butting up to this vacuum of space, right, this near vacuum, what they call a 10 to the negative 17 torr vacuum. Vast, almost infinite in size compared to this little speck dot of an Earth that we're going to maintain our atmosphere because of gravity, all right? Gravity is going to hold it down. This is what they say. I'm going to prove with this turkey baster that that's just not the case. You see, and I'm also going to show you, I'm blowing out, so the air comes out of that turkey baster flying out. Now I'm squeezing this ball right on the end of it, and it's a ball that bounces right back to its shape. So as I squeeze, let me squeeze it, okay, as I squeeze down, I flattened it and I squeezed the air out. Now, at the moment I start to let go of it, it starts to create a vacuum because it's creating a bigger container than the atmosphere that's in it. And so what happens is the air rushes right back into it. I mean, like at the split second, or I don't even know how fast, but whatever. It goes right back in. And then I squeeze it and the air shoots out. And it comes in even faster than I can squeeze it. It just, as soon as a vacuum appears, air rushes to a vacuum, much like these tanker cars, right? These tanker cars, they suck the air out of them, and boom, they smash like this. They suck the air out, and then the air molecules want to go to where there's free space, right? A vacuum is void of other molecules, and so molecules like freedom. They like to go where there's space, and they want to spread out, and so they will fill the space. So in an attempt to fill the space with this tanker, they smash the walls in. So you need to have some kind of barrier between air pressure and a vacuum, or else that happens. See, they didn't even get near a vacuum, and it collapsed. NASA has a vacuum chamber, and the walls are 6 to 8 feet thick. This is so that this doesn't happen to their little facility where they do some vacuum tests or whatever. Okay, so back to the baster, the turkey baster. So when I let go of that little, for lack of a better word, I can't even think what the little ball on the end. When I let go of it, I've just created a vacuum, and the air rushes in. Okay, now I'm going to squeeze it. I haven't created a vacuum yet. I've just taken the air out of there, right? I've made the container smaller. The container is that little ball that I'm squeezing, and I'm showing its elasticity and how it springs back. Okay, so I'm going to submerge it into the water, but first I'm going to squeeze it, right? Take all the air out of it, and I've essentially made the container smaller. Okay, so now when I let go of it, it's going to want to fill up again. The molecules are going to want to go into it, but I'm in water now. So the water is going to go in, and this is going to dispel the notion that gravity somehow is going to hold the atmosphere down to the Earth, even though it butts up against a vacuum of space, or a 10 to the negative 17 torr vacuum. That's infinitely huge and millions of times bigger, gazillions of times bigger than the Earth, right? Yet here I created a small vacuum with this plunger thing. I squeezed it, and it's pulling in volume almost its full size. And yet it's holding it. Not only did it suck all the air in, it sucked the water up. So not only would we have no atmosphere on the Earth, we'd have no water either. Because watch this, I've created a very weak vacuum. Nothing like the vacuum of space is supposed to be. And here we go. We've got water being held up by this vacuum. Now, I squeezed out maybe 90 to 95% of the air out of that ball, right? That chamber. So the water that came in is maybe, 90% full. So there's a little bit of vacuum still in that chamber at the top of the ball, and it's holding that water in place. This is nothing near what the vacuum of space is. So, and this water is maybe 90% the volume of this container, 90, 95%, whatever. So here we have, in comparison or in contrast to, this little speck of an Earth that's sitting inside this vacuum of space, which is basically infinite, right? Goes on forever. Our atmosphere is is one tiny, like a grain of sand compared to all the beaches in the world, right? This is 90% of this, and it's holding it up. Imagine what it would do to our little Earth and its atmosphere, right? So not only would our atmosphere be gone, our water would be gone too, if we were actually next to a vacuum of space and anything like that. This is just my own little animation I made, and this would be our atmosphere, and next to the vacuum, it would be gone and disperse, and that'd be the end of that. We'd all choke. We'd never. This whole thing is fantasy, that we're in a ball flying through space. Okay, we all know that. People who know the Earth is flat, but there's a lot of people that are clinging to this idea that this is even possible. Okay, now when I squeezed this, right, and then I put it in the water and then I let go, it created a vacuum, because the container is now bigger than the air volume or the molecules that are inside of it. And so everything, just like the tanker, wants to rush in and fill. And so, like I showed with the water, the point being, when the container gets bigger, molecules are going to want to fill the space. Here's another animation I did. Okay, so I start off with this, and it's a small little plexiglass container. Now, I'm going to stretch this container, but yet I'm going to keep the same amount of air molecules inside the container. So as I stretch it, it's going to become like this. It's becoming more and more vacuous and lower pressure, because it's a bigger volume and less atmosphere inside. The pressure is getting lower. It's becoming more and more like a vacuum. Okay, and I just kept stretching this up. So essentially what's happening is the container is getting bigger and the air molecules are spreading out. So it's getting closer and closer to a complete vacuum, right? And I'm stretching this up into the sky. You can just imagine this at the end here. I'll show you. So I've stretched this up high into the sky, whatever it is. Bigger volume, less pressure, because I didn't add, think of it as a hermetically sealed, airtight container, and it's strong enough to take this, increase in low pressure, this vacuum, right? So all the molecules keep spreading out. I made this so that as I actually stretched this container, the little circles in there spread out. So I haven't added or decreased the amount of molecules, little circles, and they've spread out with the stretching of the container. That's exactly what would happen on the Earth if we were next to a big vacuum container. Our atmosphere would be gone. And yes, even in this, there is some gradation or stratification of the air molecules and the particles and what have you. And we experience that on Earth. We have 14.7 psi at sea level, and it gets less and less as we go up. But the reason we have gas pressure to begin with is that the antecedent for gas pressure is a container. You have to have a container. So a pressure gradient is still gas pressure and still requires a container. And this explains why we have a gradient. Besides, we have relative density, right? Like I said, heavier or more dense particles will gather at the bottom because they're stacked up, right? And they have volume to them, they have density, they have weight. And so because we have a limited ceiling, they say, well, the atmosphere just keeps getting thinner and thinner as you go up until you hit the vacuum. Well, no, that's not possible, just like I showed in this container. As you stretch the container, it's only because the container is finite. There's a ceiling, and it's not that high of a container compared to this infinite universe of infinite vacuum. This has a limit, a container. If you opened up our atmosphere to the vacuum, the infinitely large and infinitely big vacuum of space, our atmosphere would be toast. It would be gone. So because this is a limited size container, as we get to the top here, I'll show you, there you go, there's a top to the container. But if you kept going into space with this container as high as, just keep going for like millions of miles, you wouldn't find any particles. It'd be near a vacuum, complete vacuum, and you couldn't find any particles because they will fill the space, just like I showed with the tanker. They want to get into that tanker, right? That's why NASA has 6 to 8 foot walls on their vacuum chamber, because the molecules want to get in. And so, like I showed with the turkey baster, not only would we not have any air, we would have no water. Because this vacuum that I created here, this is a mild vacuum. It is certainly not the 10 to the negative 17 torr vacuum that they say space is, which I guess means close to a perfect vacuum, out in space or whatever. But there is no space. Of course, the whole thing is a fraud, because you can't have it. This defies logic, and it defies what we see, the second law of thermodynamics and entropy. And what we observe here on Earth is that high pressure goes to low pressure. If molecules have space, and you can see with this tanker, the tanker imploding, the opposite is you blow into a balloon, like me blowing the air out of the baster. Molecules going out would cause a reverse pressure. That's why things can explode. Air pressure builds up in a container and it blows it out. Air pressure decreases in a container and it implodes, like these tankers. And as the container gets bigger, the molecules will go out into that container. And again, having this vacuum of space up against our atmosphere with no barrier between, this fantasy they call outer space, can't be, because our atmosphere would be gone. It's the nature of the particles to go out and fill the space. And gravity? Well, no, I just showed you. I'm here on the gravity ball right now doing this experiment, and the water with a very mild vacuum that I created with this turkey baster is going up into the vacuum chamber, which I made at the top. As I squeeze that, now I let go, I created a vacuum chamber at the top. And what did the water do? It filled the space. Now, this whole thing is essentially the container, the clear plastic and the ball at the top, the plunger, whatever you want to call it. It's essentially a container, and the liquid went and filled the container, much less the air. Any air would definitely fill the container as well. So this is busted. We've had a show called Globe Busters. We've got Ball Busters, but you know what I'm going to call it? Ball busted. It's past tense now. It's busted. Now it's time to let the world know. And thank you guys for tuning in and watching this. Share a link of this video so other people can see it. I've also got some t-shirts. Check out this t-shirt. It looks awesome. It's a premium tee, and I think it's heavy metal, it's called. The color looks great, fits great. It's a large. It's super soft. So check them out. Let's start getting it out there, because it's ball busted now. It's busted. It's done. Okay? All right. Thanks so much. I will be putting out more videos soon. Thank you so much for tuning in. Bye-bye.